Okay, so this is February-March 2016, mechanics paper 42. There's only one variant. Um, Here we go. Question number 1. A cyclist has a mass of this and rides a bicycle of mass this. Okay. The cyclist rides a horizontal road against a resistive force of 40. Find the total work done by the cyclist in increasing his speed from 5 to 10 meters per second while traveling a distance of 50. Okay, so this is some sort of an energy one. Okay, so if the resistive force, so if a cyclist is going moving in this direction, and then there's a resistive force of 40 newtons this way to the left, and his force is this, and 10 meters per second in 50 meters. So I guess we could find like acceleration and then use force. Yeah, okay, we can find. Yeah, okay. So I think we can just find acceleration and then find the force. So acceleration is like 2as equals v squared minus u squared. And so s is 50, so 2 times 50. So this is 100. A equals to v squared is 10, so 100 minus 25, which is 75. So a is equals to 0.75 meters per second squared. So we have the acceleration. So F is equals to ma. We know what this is the resultant force. So we know that m is like obviously the total mass, which is 85 plus 20, which would be 105 into 0.75. So that's 78.75 newtons. And then you can just find the this is the resultant force. So this is after you take out the 40 newtons of resistive force. So we just add the resultant force to 40 to find the forward force. So plus 40, 78.75 plus 40 is 118.75 newtons in the forward direction. And then work done is just force into distance. This is the driving force or the force, the forward force. And then the distance is 50. Just multiply by 50. And you get like 5937.5 joules, or like if you want to put it to three significant is just 5940 joules. All right. Okay. And then what else? Okay. Oops. Okay. Constant resistance of magnitude this, X on a car of mass this. The car is moving along a straight level road at a constant speed of this. Okay, fine. In kilowatts, the rate at which the engine of the car. Okay. So power is equals to driving force into velocity, and driving force is equals to the resistance because the speed is constant, which means the force is balanced. So 1350 into the speed or the velocity is 32. So you get 43.2 kilowatts around. The car travels at a constant speed up an inclined hill at an angle of theta to the horizontal where sine theta equals 0.1, with the engine working at 76.5. So, okay. So you have a car here, and then this is like theta. Okay. So what is sine inverse of 0.1? Like, we don't even need to find the angle. We can just use like this. So sine is just opposite over hypotenuse. So 1, and then I guess you could call this 10, like this hypotenuse length. So you have this, and then it says that okay, engine is working at 76.5 kilowatts, so you can find um the driving force will be same because actually, hmm, this is a bit weird. Okay, we can find the resistive force, right? Because okay, let's find the resistive force first. So the total resistive force would be this 1350 plus like the weight component that's acting backwards. So like, what is the weight component? The weight, okay, 1200 kg. So we can find the weight is times 9.81, which is like weight would be 11,772 newtons. And then to find this component, you can just multiply by sine theta, which is zero point 0.1. So zero point 0.1, you get the component as 1177.2. So the total backwards resistive force is 2527.2. And it's a constant speed, which means the backward force must be equals to the forward force. So power equals driving force into velocity. Power they've given us 76.5 kilowatts, or 76.5 times 1,000, equals to 2527.2 into V. So you get 2527.2. So yeah, okay, velocity is about 30.27 meters per second. Yeah, okay. Okay, yeah. All right, next question. So this is the forces in equilibrium one, I guess. Coplanar forces of magnitudes this act at a point here where tan theta equals 7 by 24. Find the magnitude and direction of resultant force. Okay, so for this you would have to find f of x, or like all the horizontal components of the forces. You have to resolve them. So this would be 40 cos alpha, 40 cos alpha. This is for, okay, so if you draw a line like this, what is this angle? What is this angle? I guess it would be theta because that's the only one given. Yeah, I think okay, yeah, this is theta because if this is 90 degrees, right? If this is 90 degrees, this is 90 degrees, right? So if you were to like draw like a line, this is like a horizontal. This is the horizontal, this is the vertical, right? So that must mean that the angle between the horizontal and the vertical must be 90 degrees, right? Like here it's 90 degrees, so this must also be 90 degrees, which means that this entire angle is 90 plus alpha, right? This entire angle is 90 plus alpha because this is 90, this is alpha. So if this becomes 90, then this and this total angle is 90 plus alpha, then this must be alpha. I hope that makes sense. So we have alpha here, and this is going to be horizontal, so this. So 30 sine alpha. And it's to the left, so it'll be negative 30 sine alpha. Okay, and then you do f of y. Fy, there's a single force upwards of 50, and then there's two downwards ones. So 40 sine alpha is down, so it'll have a negative, and then 30 cos alpha is also down, so it's also going to be negative. Now, what is this triangle? We have to find out what actually theta, or sorry, alpha is, or what tan alpha and cos and sine alpha actually are. So let's make a triangle for this. So this is alpha, and then tan is the same thing as opposite over adjacent. So 7 will be opposite. Adjacent is 24. You can find the hypotenuse by just using the formula c squared equals a squared plus b squared equals c squared. you'll find that the hypotenuse will be 25. So if the hypotenuse is 25, you can get exact values. So cos theta will be so adjacent over hypotenuse. So 24 by 25 is cos alpha. So 40 into 24 by 25, we get 38.4, and then minus sine 30 sine alpha. Sine would be opposite over hypotenuse is sine by 25 into 30, 8.4. So it'll be 30.0 newtons to the right, because this is the force to the right, this is the force to the left. Like, this is the force to the left, this is the force to the right. So if you resolve them, you find that it'll be 30 newtons to the right. Yep. And then to resolve this, you do the same thing. 50 minus 40 sine alpha. 40 sine alpha is 11.2 minus, and then 30 cos. That becomes 28.8. So this just makes it 50 minus 40, which is 10 newtons. So, okay. So basically, in the horizontal direction, there is a force to the right of 30 newtons. 30. And then there's a upward, sorry, let me make this again. So there's a force to the right of 30 newtons, and there's a force up of 10 newtons. So what will be the resultant? Will obviously be this. This will be the resultant force. We just square them. So 10 squared plus 30 squared, and then under root, because that's the formula, right? C squared equals A squared plus B squared. You have to find resultant force. Resultant force is this one. So that will be 10 root 10, which is about 31.6. So resultant force is about 31.6 newtons. Now, you have to also find the direction of the resultant force. So to find the direction, you can't just say it's to the right or it's like northeast. You have to specify an angle, the angle with the horizontal, because remember, this is the horizontal component, right? This is the horizontal component. So if you want to find the angle of a line that's like this is the resultant force. If you want to find the direction, you have to find the theta from the horizontal. So you can find it very easily by just doing opposite over adjacent tan. So tan inverse of 10 by 30 is 18.4. So theta equals 18.4. And then you also have to specify where you're taking the angle from, because you could be taking the angle from here, or you could, if it's to the left, you could be taking the angle from here, right? These both could be the angles. You have to specify that it's 18.4 or 18.5 degrees from the positive x-axis, because this is an axis, right? This is an axis. This is the positive x-axis. This is the negative x-axis. This is the positive y-axis, and then this is the positive negative y-axis. So you have to specify. So in this case, it's 18.4 degrees with the positive x-axis. Positive x-axis. Let me just positive x-axis. All right. Okay, so the second part, 1 second, actually. So R was 31.6, and then we had theta as 18.4, and then it was like this 30, 10. Okay. The force of magnitude 50 newtons, so the 50 newtons, is replaced by a force of magnitude P acting in the same direction. The resultant of the force now acts in the positive x direction. Find the value of P. Okay, so they're basically saying that okay, yeah. Okay, they're basically saying that the resultant of the three forces now acts in the positive x direction. Positive x direction was which one? Here, right? This way. which means that there is no upwards force. It's purely horizontal, which means that the vertical forces must cancel out, right? So whatever P is, right, this is P, must be equals to both of these combined, because there's no more any resultant force in the vertical direction. So we found that these two added together, uh, like their vertical components added together were equals to 40. We already calculated that because the resultant force upwards was 10, right? So if both of them, if the force downwards is 40 newtons, right? So P minus 40, because P is acting upwards. So P minus 40, it would give you the vertical resultant force. But the vertical resultant force is 0 because there's no uh, resultant force in the vertical direction. So it must be 0. So P must be equals 40. So P equals 40, and that's the question. Okay. So next we have a particle of mass 0.8 kg is placed on a table. The coefficient of friction between the P and table. Okay, the particle and table is wait, what is this called? Mu? Yeah, mu. A force of magnitude 5 newtons acting upwards at an angle theta above the horizontal, where tan theta equals this is applied to P. Okay, so we have a force on our particle. The particle is on the point of sliding on the table, which means that it's in limiting equilibrium. The friction is maximum. Find the value of mu. Okay, so I guess we make a sort of a diagram here. So we have a table, right? We have a table here. You have thingy, a particle here, and you have a force of 5 acting upwards in an angle of alpha. Okay. So like this, and this is alpha. So and the force is 5 newtons. The force is 5 newtons, right? And where tan theta is 3/4. Okay. And then there's also force to the left, which is going to be friction, which is mu r that we have to find. And the particle is 0.8 kg. So this is a pretty easy question. You just have to find out r. You have to find out the components of the 5 Newton force and then find out r. And then you can use that to find out mu. Okay, so first of all, let's find the components. So actually, let's first draw the triangle. Right, so this is alpha, and then tan is opposite over adjacent, so 3/4, and then hypotenuse is 5. You can check this using the c squared equals a squared plus b squared, but it's 5. So we know that this is 5. We can find the this one, which would be 5 sine theta. So 5 sine, sorry, not theta, alpha. So sine alpha would be 3/5. So 3/5 into 5 is just 3. So 3. The force upwards is 3. And there's also obviously R, which is the reaction force acting on the ball. So we know that these forces are balanced because it's not having any vertical motion. So that must mean that 3 plus R must be equals to the weight of this ball, which would be 0.8 and 10, or 0.8 G. 0.8 and 10 is just 8. So from this equation, sorry, not 10, 8, R must be equals to 5. Okay, so we found R. Now we can find mu after we find the forward force, or the force this way, right? Which would be just 5 cos alpha, where cos is adjacent over hypotenuse. So 4/5, and then multiply by 5, which is 4. Okay, so 4 newtons. And then the forward force is 4 newtons. And since the particle is like not moving yet, it's on the point of moving, which means that backward force and forward force are equal. So 4 is equals to friction force, and then friction force is just mu r. So 4 equals mu r. And r is 5, so 4 equals 5 mu. And from this, you get the value mu equals 0.8. Okay. Now we can just remove this. So mu equals 0.8. Okay. Mu equals 0.8. The second part says that the magnitude of the force acting on P is increased to 10 newtons, with the direction of the force remaining the same. Magnitude of the force acting on P. Okay, so this force, the 5 newton, is now changed to 10, with the direction of the force remaining the same. Find the acceleration of P. Okay. So we have to rerun our calculations. So 10 cos, wait, so 24, 5. Okay. So let's just rerun our calculations. So we can just find 10 sine alpha, which would be just 10 into 3 by 5. 10 sine alpha is 6. So there's a force of 6 upwards, r upwards, and then the weight. So 6 plus r equals 8, which is the weight of the ball. So r will be 2. Okay. Now we can find 10 cos alpha, which would just be adjacent over hypotenuse. So 4 by 5 into 10, which would just be 8. So 8 is the forward force, and then we can find the backward force by just multiplying, because backward force is friction mu r. Mu is obviously constant for any surface, so 0.8 into 2. R was 2, so 0.8 into 2, we get 1.6 newtons backwards, and 8 is forward, so forward minus backward equals ma, right? Forward minus backward equals ma. Forward is 8 minus 1.6 is backwards, and mass of the thing is 0.8, 0.8 a. So divided by 0.8. So you solve this, you will get a to be, you will get a as 0. Wait. Oh, sorry. A as 8 meters per second squared, which is the answer. Okay. All right. Now, okay, this fifth question. How many are... Okay. A car of mass 1,200 kilograms is pulling a trailer of mass 800 kilograms up a hill inclined at a angle theta. All right, so it's like this. Boom, boom, boom. We have, I guess, a car and a trailer. So car, trailer. So this is 1,200 kilograms. This is 800 kilograms. And then this is theta. Sorry, alpha. Alpha. Sine alpha equals 0.1. Okay. The system of the car and the trailer is modeled as two particles connected by a light, inextensible cable. The driving force of the car's engine is 2,500, and the resistances of the car and to the car and trailer are 100 newtons and 150 newtons, respectively. Find the acceleration of the system and the tension in the cable. Okay, so we just have to make two different equations, solve them simultaneously. So it says that the driving force of the car's engine is 2,500, so we can make like a force diagram, or like we can solve for the forces on the car. So forward minus backward equals ma, right? Driving force, which is forward force, is 2,500 minus resistances to the car and trailer are this. So resistance on the car is 100 newtons, and then there will also be a tension backwards. So minus T equals ma. M is 1,200, and we do not know the acceleration. Now for the trailer, trailer, the forward, it does not have its own driving force. Its forward force is the tension in the cable. So forward force is T minus there's a resistance to the trailer of 150 newtons. And oh, yeah, we're also supposed to. Okay, never mind, never mind. Right. There's also going to be the what you call it? The weight. Yeah, there's also going to be the weight. Okay. Yeah. So the weight of this would be, let me just rewrite this. 1200, sorry, not 1200, 2500 minus 100 minus T. And then the weight of this acting backwards. So minus 1200 times 0.1, which is, because this will be 1200 sine alpha, and sine alpha is just 0.1. So 1200 A. Okay. And then trailer will just be T minus T, which is the forward force minus the resistive force minus the same thing with 800 times 0.1 equals to 800 A. So let's just solve this. So 1200 times 0.1 is 120. So this will just be 2500 minus 120 minus 100. So this just becomes 2280 minus T equals 1200 A. So T will just be equals to T will be equals to 2280 minus 1200 A. So we can just swap this into this. 1 second. 2230 equals 800 A. Right? So we know the value of T. T will just be 2280 minus 1200 A. Or actually, I could just, no, never mind. Let's just swap this. So if you swap this, that you put T equals to 2280 minus 1200 A, you get 2280 minus 1200 A minus 230 equals 800 A. So 2280 minus 230 is 2050 equals to, I guess, 2000 A, which becomes like, wait, have I done something? I think I made some, did I not multiply something? I think I forgot to multiply something, wait. Yeah. I forgot, okay. Yeah, okay. Never mind. Yeah, this is not 800, it's 8,000. Okay, yeah, this is 8,000, because that's the mass. We need the weight, because the weight component depends on the weight, not the mass. So you have to multiply them by 10. Okay. Yeah, okay. So minus 12,000 times 0.1, which just becomes, okay, I have to do this again. Okay. 2500 minus 1200 minus 100, you get 1200 minus T. 100 minus T equals 1200 A. Okay. And then here as well, I have to change this. So it'll be T minus 950 equals 800 A. So you just swap out T. This becomes 1200 minus 1200 A equals minus 950 equals 800 A. So 1200 plus 950. Wait, this is giving me the same answer. What is going on? What is this? What? Wait. Okay, let me try and do this again. Wait. So T is equals to 1200 minus 1200A. And from here, T is equals to 800A plus 950. So if you equate both of these, right, if you equate 1200 minus 1200A equals to 800 plus 950. Okay, I think now it's fine. I probably did some mistake. Because this goes over here and it becomes minus, so it'll be 250 equals 2000. And A will be just 1 by 8. Okay, yeah. Yeah, okay. A will be 1 by 8, or 0.125 meters per second. Yeah, okay. I got it. Okay. Okay, yeah. And then we can just put this A into any one of these equations. Let's just put it into this one. So T minus 950 equals 800 times 0.125, which is 100. So T will be equals to 1050 newtons. Okay, there we go. There we go. Given in... Okay, where am I going? This is it. When the car and the trailer are traveling at... Okay, 1 second. Let me just erase all of this. We don't need it anymore. The acceleration was 1 by 8 and tension is 1050. Or was 1050. When the car and trailer are traveling at a speed of 30 meters per second, the driving force becomes 0. When the cable remains taut, find the time in seconds before the system comes to rest. Okay. So essentially they're saying that the forward force becomes 0. Yeah, the forward force is 0 because yeah, okay. So basically they're saying that there's no forward force and then the only forces acting are the backward forces. So we have to use that. The only forces acting are the backward forces. So let's do that. Okay. There's also no tension because the spring remains taut. Okay, no, sorry. What? The cable remains taut means... Actually, we don't even need... Would we need tension in this? I don't think we would need to include it. Well, we can just check. Because if you use the system, you don't need to include tension because it will just cancel out. So we can just use the system and not worry about the tension. Because if you use the car or the trailer, then you would have to include tension because there's only one, because it will actually act. The tension will have an effect because it won't be canceled out because there will only be one tension. But in system, there's two tensions, but they're both equal and they're both opposite, right? So we can just use a system. So it's just forward minus backward equals MA. There's no forward force anymore, so it's just backward. So backward would be 1200, 12,000 times 0.1, which is just 1200 G sine alpha, minus 800, 8,000 times the same thing. And then I guess 100 and 150 as well, because they're constant. 100 and 150 is just 250 equals MA. M is just 2000, so this is 2000A. And now let's just calculate this: 1200 plus 800 plus 250, 2050. So the acceleration is... Sorry, 12 to G, 250. Oh, wait. Huh. 2000 times 10, or 2000 plus 250. 1200 plus 800 is just 2000 and 250. You get 2250 equals 2000 A. So just divide it and you get A as 1.125, or which will obviously be negative because it's backwards. It's deaccelerating, so we can find the time we're just using v equals u plus at. We know that the final must be 0 because it will come to rest, and then u, they've already told us, is 30 minus 1.125 t. So the time, if you solve this, will be 26.6 or 26.7 meters per seconds, or an exact fraction is just 80/3. Okay. Just 1 second. All right. Two particles, this is question number 6, two particles, A and B, of masses 0.8 and 0.2 respectively, are connected by a light inextensible string. Particle A is placed on a horizontal surface. Okay, so one of them has a horizontal surface. The string passes over a small pulley fixed at the edge of the surface, and B hangs freely. The horizontal section of the string AP is of length 2.5. Particles are released. Okay, so there's a pulley here, or on the left side, it doesn't really matter. And you have a particle A connected to the pulley, and then you have B. Yeah, okay. So this is B. This is a pulley, and then A to P is 2.5 meters. This is 0.8 kg, and then this is 0.2 kg. The particles are released from rest with both sections of the string taut, so there's tension. Tension is this and this. Tension will always be away from the object. So, given that the surface is smooth, find the time taken for A to reach the pulley. We just use the normal equations, to find tension and acceleration that you do in every single one of these questions, like these pulley ones, where you use simultaneous equations to solve for T and A. So, A, the forward force for A is T because T is acting here. It's going to go, actually, wait. Is it going to be able to move it? Yeah, it is. Because you want to actually make sure. Because here it's pretty clear that B is going to move it because there's a force acting downwards. And then there's no force here. But if it was like this, and this, you would have to make sure which way it's actually going to go before you do it. But here it's pretty clear. So if forward force is T minus, and they said that the surface is smooth, so there's no backwards force. So it would just be T is equals to MA, because it's forward minus backward, equals MA, right? So M is 0.8, A. B is going to be the weight, which is 2, minus the tension. Tension is acting upwards, equals MA, so 0.2 A. So since C equals 0.8, you can just do this. And A will be, I guess, 2. Yeah, A will just be 2. And then you can just find tension as 0.2 times 0.8 times 2 is 1.6 newtons. Or actually, you don't even need to find tension. They've asked for time taken, actually. So yeah, you know the distance, you know acceleration, you know that it's starting from rest. It says particles released from rest. So you just do S equals ut plus half at squared, and then u is 0, because it's starting from s, so you can cancel this out. And distance 2.5, 2.5, 1/2 into 2 into t squared. So t equals to 1.58 seconds, or around that. Okay, so we can just clear this out now, I guess. Okay. Now in the second part, they've asked that, okay, now the surface is rough, so there's going to be friction here. Okay, and they've given you the coefficient. Find the speed. Okay, so coefficient of friction is 0.1. We have to find F first, which we can, so we need to find R. R will just be, what will R be? R will just be the downward force, because this is R. Upwards and downwards forces must be equal, so R is just 8. So 8 newtons, and 8 into 0.1 is just 0.8. So back F, or frictional force, is 0.8. So we can again make two equations for A and for B. So it's going to be tension minus 0.8 equals to 0.8A. And then for B, it's 2 minus T, the same, equals to 0.2A. So T will just be 2 minus 0.2A. So 2 minus 0.2A minus 0.8 equals 0.8A. So it'll just be 1.2 divided by thingy. And acceleration will be 1.2 meters per second square. And you just use the same formula, s equals ut plus half at squared. Distance remains the same, u is 0, so half into 0.12 t squared, 2 divided by 2, 2.5 divided by this, and root, you get 2. 1 second, what? Oh, sorry, we're supposed to find velocity, not time. Never mind. Yeah, okay, we're supposed to find speed of A. Speed. Okay, so it'll just be V equals U plus, no, because we don't know time. So I guess it'll be 2AS equals V squared minus U squared. So 2 times 1.2 times 2.5 equals V squared, because U is just 0. So yeah, okay, its V is 2.45 meters per second. That is that question done. Okay, so this is the last question, question number 7. Particle P moves in a straight line. The velocity V at time t is given by, and they've given us 3 different equations for 3 different times. This is K. Find K. Okay, so a small concept here for variable acceleration is that suppose there's a ball here. This is t equals 0, and this is t equals 4. Right? There will be a certain velocity v here, and when you calculate this velocity by inputting the time 4 into this equation, it should be the same as if you inputted it into this equation. So we can just find that. So if you input 4, which is time, into this, you get 20 to 40. So k is just 40, because the velocity here must be equals to the velocity here, and 40 equals v must be 40. Okay, so k equals 40. Sketch the velocity time graph for 0 to 20. Okay, so so we can just check something. So the first equation is 5t squared minus 10t. So that's a quadratic. Yeah, okay, it's a quadratic. So let me just make this, and this will not be the best graph, but it's just a way to represent it. So it will be a graph like this, right? Yeah, okay. So we can find the velocity at 0 by just inputting 0 into this. It will be 0, right? And then we can find the maximum, I guess. Yeah. We can check it at different times, but V0 is we can check it at thingy at different times. But yeah. Let's check it at 2 into 2 minus 2. So okay, yeah. At time 2, it's also like let's actually put timers here. So I guess we can put this as 20, and then we'll see later. But yeah, it's also thingy at 2, because if you put 2 time into this equation, 2 minus 2 is 0, so it'll just give you 0. So velocity is 0 at 2. And then at t equals 4, it's 40. So it will be like this or something like that, yep. So it'll, see. Actually, wait, funding. Let me do this. Okay, wait. So it's kind of like this, boom, or like boom. Yeah. And then you can continue this. Wait, I can make a graph for my life. Okay. Yeah, it's sort of like that. Like that, like a quadratic curve type. And at 4, it's 40. And then it'll be like constant. Let's put 4 ahead actually. Whoops. So it'll be like that. So this is 4. And then from 4 to 14, let's put 14 like here, I guess. It'll be constant because v equals k and then k equals 40. So v is just 40. So it'll be constant from here to here. And then let's see, it's 68 minus 2t, which means that it's a straight line because it's not a curve. And it means that as time increases, velocity will decrease, right? Because if you have time 2 here, velocity will be 66. If you have time 1, if you have 15 here, right? If you have 15, the velocity will be 38. If you have 20, right, 2 times 20, the velocity will be 28. So it's decreasing. Yeah, okay. So it's decreasing. And let's just make a horizontal line. This will be 28. Or yeah, this will be 28. So 20, 28. 20 comma 28. This is just 4 comma 40. 14 comma 40. And then this is just 0 at 2 seconds. You have to mark some of this stuff. But yeah, apart from that, it's fine. So just t seconds and then velocity ms. Okay. Yeah, and then this will be minimum at 1. So 5 into 1 and then into 1 minus 2. Sorry, 1 minus 2 into 5. So this is minus 5. This is the minimum. Yeah, okay, this is the minimum, and that's the entire graph. Okay. Next, we have find the set of values of t for which the acceleration of p is positive. So, okay. So here the acceleration will be negative because velocity is obviously decreasing. Here its acceleration will be 0 because the velocity stays the same. Now we have to find positive, which means the velocity must be increasing. So we saw that the minimum for this equation, so the minimum for 5t squared minus 10t, the minimum point for this is actually t equals 1. So from t equals 1 all the way to t equals 4, the thing is accelerating, right? There's also another way to find this, right? You can just do you can just differentiate this, and you get like 10t minus 10. And then put this equals to 0 to find the stationary point. So t will just be 1 second. So you know that the stationary point is this, right? When acceleration is 0. So t equals 1, acceleration 0, and before that, the velocity was decreasing. So after this, the velocity must increase all the way till when we have constant velocity. And that's t equals 4. So from t equals 1 to t equals 4, the acceleration is positive. Positive, so the range, the set of values would be just 4. Because at 1, it's 0, so it's technically not positive, because 0 is not positive or negative, so you have to do this sign. And then at 4, it is positive, because if you put this into 4, if you find the gradient of this equation at 4, do 10 into 4 minus 10. It's 40 minus, it's 30, which means that there is acceleration, right? There's acceleration, but if you put like, I don't know, 1, yeah, if you put t equals 1 into the gradient equation, you will get 0. So the acceleration is 0, not positive. Okay. So the last question is find the total distance traveled by p in the interval 0 t to 20. Okay, so there's a bunch of ways you can technically do this, but I'll just do integration simple. So to find s, you just you integrate this equation 5t squared minus 10t with respect to dt, which will get you 5 by 3 t cubed minus 5t squared plus c. But you don't really need that because you're finding a quantity. It doesn't really matter. So, and then you apply limits to this. The limits will be from 0 to 4, by the way. So 0, actually, wait. If you want to find distance traveled, wait. Ah, okay. Yeah, I think you have to do it because, yeah. Because then it'll give negative. Because the actual curve is like this, right? Or like this. And this is the x-axis. And this is 0, this is 2, this is 4. If you were to apply limits from 0 to 4, this will be considered negative, and then this will be considered positive, so they will cancel each other out. They're not asking us for displacement, they're asking us for total distance, so you have to do it separately so that you can get the distances. So you do 0 to 2, and then you will add this with this dq minus 5d squared from 2 to 4. 2 to 4. And I think this is like, this was just negative 20 by 3 plus like, there's like 100 by 3. And then you'll obviously remove this sign because you want to find the total distance. So 20 by 3 plus 100 by 3 gives you 40. So that will give you 40. And then if you want to find the area, because the graph is like this, right? This was this, and then this was 4, this was 14. And then there was a straight line from 40 to 20. From 14 to 20, sorry. The maximum was 40, so you can just, this forms a rectangle. So you can literally just do this. You can just find the area under the graph, which would be 14 minus 4, 10 into 40, which is 400. And then to find this last one, I think the thingy was like, what? What was it? What was the speed here? I think it was, oh yeah, it was 28. So it fell to 28. So it was like this. Up here, so here it was 1420. Here it was 40. And then down here was 28. So you can just find it using area of triangles. So half into 6 into, I guess, 12. So 3 times 12 is 36. Oh, actually, wait, what? Wait, this is weird. Oh, because you have to take the graph underneath this as well. Yeah, okay. So this is just the triangle, and then you have to take the graph underneath, which is just 6 and 28. Right, 6 and 28, so plus 6 times 28, again. 6 times 28 plus 36 equals 204. So you just combine all of this. You combine this, this, and this. You get 644 meters. Meters as your total distance. By the way, the reason why we took this area down here is just, let me just show you. Let me erase some of this. So imagine you have a graph like this, right? And then it goes like this here, and sorry, here, here, and then it goes here, and then like it kind of stops, right? So when you're finding out the area, it's area under the graph. That is the distance. Now, if you're gonna find this area, this is not the area under the graph. The area under the graph is this entire portion. Yeah. So just like the graph we made, this was 40, this was 28. So you're not at the x-axis yet, right? You're not at the x-axis yet. You cannot. The area under the graph is the area fully under the curve till you meet the x-axis. Like if I were to do the area of this triangle, I'm doing it from here all the way to here. So if I want to take the area of the this line, right? I want to take the area from 14 to 20 seconds. I would have to do from here all the way down here. So a good way to do that would be to apply the trapezium formula, or you can just separate both of them and then use triangle, because this is a triangle, this is a rectangle. And this is 0, this is 28, this is 40. So the height of this triangle is 12, and then its base is 6. Here the bases remain same. And then since this is 0, this is 28, this would be 28 as well. So you can find, that's how you found it. Okay, and I think that's it. That's all of the questions. Yeah.